So welcome to this next lecture where we will be discussing about the different kind of systems of units which is used in oil field. So conventionally we are used to MKS system, CGS system, SI system. Okay, but in oil field we use different system. We call it as imperial system or oil field systems. Okay, so if we look at the first quantity which is mass, the SI unit is kg, and in oil field or the imperial units we use pounds. Okay, so the simple conversion will be 1 kg is equal to 2.20462 pounds. So this unit conversion is not required. We just need to understand what are the major differences between the units that are used in SI units and the units which are used in the imperial units. The length in SI units, it is measured in meters. Okay, in oil field units, we are using feet. Similarly, for time, in both the cases, we use seconds. In case of force, the SI unit is Newton, whereas the imperial unit is LP or pound force. Okay, so 1 Newton is equal to 32.17 pound force or LPM into feet per second square. The pressure in SI units is given by the formula pascals, has a unit pascals, whereas in our imperial units we have PSI. Okay, so power again it is watt. Here we use horsepower. Viscosity we use poise. Here we use centipoise. Now, if you look at the pressure, the formula for pressure is rho g h. Okay, but we know that g is a constant, and when you do the unit conversion, we come to this point where we have conversion of power pressure as 0.052 rho gh. Sorry, rho h. G is not it. This is a mistake. So you get pressure as 0.052 rho h. And this is a very important formula because we are going to use it again and again, not only in drilling, but in again other subjects. But remember that the density will always be given as ppg, that is pound of mass per gallons or pounds per gallon. Okay, and height will always be in feet. So these are the two things that we need to remember. The formula of pressure is 0.052 rho h. Okay, where rho stands for the density in ppg, h stands for depth in feet. Okay, so let's start with one numerical basic. It's a very simple numerical. We are talking about density, mass, and volume. We know that density is given by the formula. Density is given by the formula mass upon volume. Okay. Before we start with this, I would just like to explain a very basic concept of density, mass, and volume. Let's say you have two bucket of water, okay, which is complete, which is filled. Okay, this has 1 kg. Okay, this again has 1 kg water in it, and let's say the volume is 1 liters. Okay, volume is 1 liter or 0.001 meter cube. Let's just instead of just take this as 1 liters. Okay, this also being a water has the same density again has water of 1 liters. Okay, now what I do is I am going to add these two bucket and I use a bigger bucket. Okay, I pour this into the bigger bucket. So now, if you look at the bigger bucket, the weight, so if you look at this, the density, what is the density here? Density is 1 kg upon 1 liter for both the cases. Okay, so here for both the cases, we have density as 1 kg per liter. Okay, now what I do is I add these two bucket of water in the second bucket or the third bucket, okay, which is a bigger bucket. So what we get here is we will get 2 kg of water, and what will be the volume here? Volume will be 1 liter plus 1 liter, that is 2 liters of volume. So if you look at this, whenever you mix two liquids or two substance, you can say two matters, the mass increases in the same proportion, the volume also increases in the same proportion. But if you look at the new density here, the density will be 2 kg upon 2 liters, okay, which is 1 kg per liter, which means the density doesn't change when you mix two fluids of the same density. Okay, so this is one thing which we need to consider, that you cannot directly add. I cannot add the density. So this has 1 kg per liter density. This bucket again has 1 kg per liter density. So if you add, you are not going to get 2 kg per liter density. Okay, so density calculation is bit different. So you cannot calculate the value of density directly. What we need to do is we need to first calculate the total mass, and then we need to calculate the total volume. And once you get the total mass and total volume, then you can calculate the density. Okay. So what we are going to do is, there are three terms which are involved here. So that is density, mass, and volume. So we will create a table. So there are a lot of components. So let's just read the question. So calculate the density of a mud in ppg. ppg is a new unit for you, so we are first going to start few numericals based on the standard units which you already know. Then we are going to use a unit conversion to convert the value of density into pounds per gallon or ppg. Okay, remember ppg is pounds per gallon, so I will just write it for your reference here. So ppg means pounds per gallon. Okay. So now pounds is a unit of weight or mass, and gallons is a unit of volume. Okay, it's an oil field unit. So now what we have here is, so we need to prepare a mud, okay, of various compositions. There are different chemicals involved. And what is given is that the volume of water that we are going to use is 250 ml. Okay, we need to calculate the density of a mud in ppg. Volume of water is given to 50 ml and 5% by weight of water of bentonite. So whatever weight of water you get, bentonite will be 5%. Okay, 5% by, see it is mentioned 5% by weight of water. So whatever water you get, you will use bentonite equal to 5% of the weight of water. And the density of bentonite is given 1.2 grams per ml. The density of water is given 1 gram per ml. Density of barite is given 4.5 grams per ml. And the weight of barite used is given 45 grams. Okay. So you have all these units in grams and ml. And so definitely you are going to get the density also in grams per ml. And finally, they have given a unit conversion, which will be, we will be using this in the last to convert all the values, whatever density you are getting, into pp. Okay. So let's start by the first step will be create a table and fill all the given data values in the table. So whatever values we are given here, calculate all the unknown values. So here you can see water, we have volume, but we do not have the mass of volume. So if we can calculate using density of volume. So we will use this formula, that is density is equal to mass upon volume, to calculate the unknown parameters. And once you calculate each and everything, you will total the mass and you will total the volume, and then you can get the density by the formula mass upon volume. So this has to be the always, this is the steps or method in which we need to follow. We will first calculate individual mass and individual volumes, then we will add up all the mass, we will add up all the volume, and then we will calculate the density. So once you are done, you can convert the final value into ppg using the given conversion. So you do not need to remember this as such. Okay, so this will be given. Now let's start by creating a table. So you have your table, right? So let's just see what all things we have. First thing that we have is volume of water. Okay, so I will just going to write the volume of water as 250 ml. Okay, so mass is in gram, volume in ml, and density in grams per ml. Next, what we have is 5% by weight of water, but we do not know what is the weight of water or mass of water. So let's look at the other parameters which is given. Okay, so density of bentonite is given as 1.2 grams. So let's look where, okay, we have bentonite here. So density of bentonite is 1.2 grams. Next, what we have, density of water is 1 gram. So density of water is 1. Okay. Next, what we have is density of barite. So density of barite here we have it as 4.5. Next, what we have weight of barite as 45 grams. Okay, so weight is mass, basically 45 grams. Now, let's start by finding what is the mass of water. So basically you have density equal to mass upon volume. So mass, if you try to convert this formula, what we get is mass is equal to density into volume. So to get the mass of water, what we will do, we will multiply the density of water and the volume of water. So that is 1 into 250, which will give me 250 grams. Okay. Similarly, if I want to calculate the volume, what I am getting here is from this formula, volume will be mass upon density. Okay. So here you can say that, okay, I want to calculate the volume. So I have mass which is 45 grams. I have density 4.5. So volume will be 45 upon 4.5, which is 10. Okay. Now for bentonite, what they have mentioned is that bentonite is 5% by weight of water. 5% by weight of water. So weight of water is 250. So what will be the bentonite? It will be 5% or 5 upon 100 into 250, which is equal to, you can do the calculation. Let me just do the calculation. It is 250, which is equivalent to 12.5. Now again we have the mass of bentonite as 12.5. So what will be the volume? Volume can be calculated using the formula mass upon density. So I will write mass is 12.5 upon density is 1.2. So 12.5 divided by 1.2, which is equal to 10.42. Okay. So you, step one and step two is done. You added all the known values. You did the calculation. Now what we are going to do is we are going to add the total mass. So what is the total mass? If I add 250 plus 45 plus 12.5, I get 250 plus 45 plus 12.5, which is 307.5. Similarly, if I add all the volume, I am getting 250 plus 10 plus 10.42. You get volume as 270.42. So this is a total value. Now what we have, the formula is density of your mud will be total mass, or you can just write mass upon total volume. Okay. So total mass we have 307.5 upon total volume is 270.42. If you do the division, you will get value as 307.5 divided by 270.42. You get value as. So let us try to write it as accurate as possible. 1.13712 grams per ml. Okay. Now, if you look at this value, you will notice that there is a unit conversion given. Ki 1 ppg is 0.01198 grams per ml. Sometimes what happens is, most of the time you might get confused ki whether I need to multiply or divide it. So what we are going to do is, let's say I have 1 ppg. This is your basic understanding, which is equal to 0.1198 gram per ml. Okay. And what we have density in grams per ml. So basically it has to be here, right? 1.13712 grams per ml. Now I need X, which is a value in ppg. So what we need to do is we need to do the cross multiplication. Okay. So what we are going to do, if you do the cross multiplication, 1 into 1 will be same value, you will get 0.012 x ppg. So basically I am going to get 0.1198 x equal to 1.13712, which means I can find x by using the formula dividing it. So 1.13712 upon 0.1198. So remember, this is just a rough work. So based on this unit conversion, how to identify whether you need to divide or multiply is basically you write it in this manner. Okay, and then you identify, okay, so get the value of x, I need to divide this. So here what I'm going to do is I'm going to divide this 1.13712 by the value 0.1198 to get the density in ppg. So let me divide it and get an answer. So what is the density I'm getting? 1.13712 divided by 0.1198. So you're getting something around 9.49 ppg. Okay. So this is the final answer. So easy calculation, you fill in the known first whatever data is given, try to identify all the known values by using the formula, all the unknown values by using the formula density equal to mass upon volume. And once you're done with that, you add all the mass, you add all the volume, okay, and divide it to get the density. Once you get the density in whatever unit we are getting, here we are getting the density in grams per ml, then you can convert this using the unit conversion. Okay. Second question, see if you look at the previous question, all the data was given and you were told to find out what is the density. Okay. Now, second question is a bit different. Here, if you read the question, let us read the question. We need to prepare. So now they are not asking you to calculate the density of mud, but they are asking you to prepare a water-based mud of density 12 ppg. Okay. In previous case, the components where you mix something and you get a density of mud, right? Now here, what they are asking is you need to prepare the density mud of density 12 ppg. Now calculate the weight of various composition required if the final volume of mud should be 600 ml. Now, why this 600 ml is? So basically, let me just tell you that mud is prepared in lab. Okay, so in lab you use mud. The mud is prepared by using a blender. Okay, and this blender generally has a volume of 600 ml. Okay, it is just a standard thing. So that's the only reason we need to prepare a mud which has 600 ml volume. Okay, and the density that we have is 12 ppg density. So this is the condition. So this is how you need to work in your labs also, right? In actual Halliburton or Schlumberger labs. Now, what other data is given that 5% by weight of bentonite, by weight of water of bentonite. We know how to calculate this, right? Once you get the volume of water, we can try to come up with some calculation and get it. The next part is density of water is given, density of baryte is given, okay. But you need to look here that the volume of water is not given. The volume of mud is given, but the volume of water is not given. Again, what we are going to do is we are going to first convert the density 12 ppg because all the values are given in grams per ml, okay. And then we are going to come up with our chart. So what is the chart here? So let's see what our data is given. Okay, so first data that is given is water density is given. Okay, baryte, let's see if baryte, okay, baryte ka again density is given 4.5. Bentonite, okay, density is given 1.2. Okay, but all the other, there is no details about anything else. Now what we can do here is in such case, so it is a different kind of question where the density of mud is given. Remember, where the density and volume of mud is given. Okay, and all the other things are unknown. So what we do is we will first assume that we are working on 1 gram of water. Let us assume that the mass of water, it can be any number. It can be 10, 20, whatever number you prefer, but I am taking one because it will be easy for calculation. It will be easy for calculation. So what we are going to do here is, let us assume that mass is 1 gram. Mass of water is 1 gram. So what will be the volume? Again, we can look at the from this formula density equal to mass upon volume. So first formula that we get is mass equal to density into volume, and the second formula that we get is volume equal to mass upon density. So volume, we need to find volume, it will be mass upon density. So it is 1 upon 1, that is 1. Next, bentonite is again, it is given by 5% by weight of water, 5% by weight of water. So we can write it here as 5%. So basically what will be 5%? That is 5 upon 100 into 1, which is equal to 0.05. So let's calculate volume. Volume formula we have mass upon density. So volume will be mass is 0.05 for bentonite upon density is 1.2. So do the calculation. So it comes to around, we do the calculation a minute. It is 0.05 divided by 1.2. It comes to 0.0417. Okay. So I'm just approximating the value to 4 digits. Now, the next thing is barite. See, always remember, barite is one of the chemicals which is used to increase the density of your mud. Okay, so density of water, if you look, this is just something to note. Density of water in your oil filled units. So we know that the standard density of water is basically 1 kg per meter cube, or you can say 1 grams per ml. Okay, so in oil filled units, density of water is 8.33 ppg. Okay, so this is the density of water. So if you want to just have a mud which has 8.33 ppg, you can just use water. But if you want to increase the density, so what we use is barite. Now, remember in the previous question also we were talking about barite. In this question also we are talking about barite. So just to remember, I'm just going to write it here. See, barite is used to increase density. Okay, and bentonite is used to increase the rheology. What is rheology? We will understand. Rheology is basically the plastic viscosity, the yield point, the gel strength, all those terms. We will discuss this in detail in next lecture. Just understand, remember this. Variety is used to increase the density and bentonite is to use for the rheological properties. Now we do not know what is the mass of barite. So what we are going to do is, let's just assume the volume of barite is X. You can assume the mass of barite, not a problem. But here I am assuming volume as X. So what will be the mass? Mass will be density into volume. Density into volume is 4.5x. Okay. So you have some things which are unknown and you have assumed few things. Okay. So it's fine. So what we do now, let's do the addition. So what, once you do the total, what I'm going to get is total mass is 1.05 plus 4.5x and total volume is 1.0417 plus x. Okay. Now we have mass as well as volume, but these are in terms of x. So let's see what is the density of mud. Again, we know the formula ki density of mud is equal to total mass upon total volume. Okay. So we know that density of mud is given 12 ppg. We use a unit conversion. See, ppg to grams per ml, you multiply. So I got the density as 1.44. So I'm going to write 1.44 equal to total mass is 1.05 plus 4.5x upon 1.0417 plus x. Okay. So once you do the cross multiplication, you solve everything, you're going to get x. So I have solved this. So let me just write it again. So x is 1.1467. Okay. So I'm not going to solve it here. You need to solve it. So x, I am getting 0.147 ml because I'm taking x as mass. So volume of the whole, that is the volume of barite is 0.147 and what will be the mass? So mass, that is 4.5x will be 4.5 into 0.147, that is equal to, let's do the calculation, 0.147, that is 0.6615. Okay. Now, if you look at this final calculation, you got all the unknowns. So you have the value of 4.6. So let me just write this here. So after you put the values, get x as 0.147 and this 4.5x you get it as 0.6615. Okay. Now you have all the volume and everything. But if you look at this, you will see that the total volume, what is the total volume now? Total volume is 1.0417 plus x, that is 1.0417 plus 0.147, which is equal to, let us do the addition, 1.0417 plus 0.147 is equal to 1.1887 ml. Okay. Now, so this was because you assume the mass of water as 1 gram. So for 1 gram of water, you are getting some values like this, right? Now what our requirement is, we need 600 ml of mud. But what based on these calculations, what we are getting is, we are getting 1.1887 ml of. So now here, what we are going to do is, we are going to calculate a new term which is called as multiplication factor. So what is a multiplication factor? It is required volume of mud upon the total volume that we get. Total volume. Okay. So if you put the value, you get the required volume is 600 ml and the total volume is 1.1887. So you get the multiplication factor as 600 upon 1.1887, that is equivalent to 5.4.75. Okay. So now what we need to do is this multiplication factors. So multiplication factor will be multiplied to each mass, to the mass and volume of each component. Okay. So basically, what will be the mass of water? Mass of water will be 1 into this multiplication factor, that is 5.4 504.75. Similarly, mass of chloride will be the actual mass after calculation is 0.6615. You will multiply with this. Similarly, bentonite, the mass is 0.05. You multiply with this. The volume of water is 1. You multiply with this. So each and every term you will multiply with this, and there will be a new table. So let us just try to PPT here. Let me just try to. So let me just delete few terms. Okay. And let me just add few terms here. Okay. So what I need to do is, we need to create a new table, right, based on all the available data. So let me just write it. So after calculation, we got this as 0.147. This was 0.6615. This value is 0.417. Okay. Final volume and final this final mass we got it as. So let me just check what are the final mass. Final mass. So if you just add this up, you will get the final mass. You just add it up. 1 plus 2.06615 plus 1.7115 and final volume we got it as 1.1887. Okay. So now we need to create a new table. So I will just keep some space. Density will be always remember density under any circumstance is not going to change. Okay. Density is always constant for any pure fluid. Okay. Pure chemical. So let's look at this thing now. After you did the calculation, means after the multiplication factor is into picture, what we have here is the mass of water. This is for 1 gram of this. So now we need to create a new table where I need to remove this. Okay, again I need to remove this. So this is the actual volume. So now this table is for the volume of 600 ml. So 600 ml of mud, new table. Okay, so we need to multiply each term with multiplication factor. That is, multiply this by, where is the multiplication factor? 600 upon. So we got, what was the multiplication factor again? Let's calculate 600 divided by 1.1887. That is 504.75. So you multiply this by 504.75, you multiply this by 504.75, again you multiply this by 504.75, multiply this by 504.75. Same for bentonite, multiply this with 504.75, multiply this by 504.75. And final mass is again 504.75. You multiply this by 504.75. And you will notice that once you do this multiplication, you will get the final volume as 600 ml, which is our required condition. Okay. So very easy numerical. Just try to practice this more and more. So let's just move on to the next topic. But before that, just understand how you did the calculation. Let us just go back. Okay. So this is the first, second numerical. Let's put so table what we did, we tried to fill in all the unknown values, but as the volume of water was not given, we assumed the volume of water as 1 gram. Okay, and you did all the other calculation. You assumed the volume of variety as x. Okay, and then you added it up. You know the density of mud. Density of mud was calculated and converted into 1.44 grams, and then you will all find out the value of x, then find the volume and then the mass by putting the value of x. Then the important part is this multiplication factor. Okay, so calculation of multiplication factor is the required volume of mud upon total volume, and then you multiply this with each and every term. Okay, so once you multiply this with each and every term, you get the final answer. Let's move to the next topic. So basic understanding, what is a force? I guess everyone knows the formula. It's a simple revision of your concepts which you have already learned. Force is nothing but mass into acceleration. Okay. In oil and gas, we use mass as pound and gravity is as different units. Okay. So if you do the conversion, gravity meter into feet and all those things, you get gravity as 32.17. So the force or 32.17 pound feet per second square is equivalent to 1 pound force. Now force again mass, we know that mass is equal to density into volume. Okay. So density is volume is nothing but area into height. And if you take the area on the other side, you will get pressure. So what is the formula for pressure? Pressure is force upon area. And from the previous question, previous term, we can so see that force can be given with the formula rho A H into G. Cancel out A and A, you get pressure as rho G H. And by some unit conversion, we get pressure formula as 0. So this is the term which is important, 0.052 rho H. Pressure is always given by the formula 0.052 rho H. Okay. Similarly, power has some units and there are some viscosity. I just want you to go through this PPT. Okay. And in the next topic, we will discuss how to increase mud density and how to dilute the mud or decrease the mud density. Okay. Thank you.